Welcome back, everyone. How long heat gets trapped near the Earth's surface determines the global temperature, but the lack of adequately measuring this time delay is the greatest weakness in the global warming theories. The public often gets the wrong impression of the greenhouse effect from illustrations like this suggesting CO2 is trapping heat forever. A comparison of the time-delayed cooling by three different mechanisms of trapping heat calls into question how each mechanism contributes to global temperatures in extreme weather. Other heat-trapping mechanisms by sea ice, clouds, or urban surfaces won't be discussed here. Now, undeniably, greenhouse gases delay the escape of infrared radiation back to outer space. In contrast, heat domes that produce heat waves don't trap radiation, but suppress the normal convection processes that normally carries heated air away from the surface for days and even months. The ocean's salty subsurface layers also suppress ocean convection, trapping ocean heat for days, seasons, and years. And that trapped heat intensifies hurricanes and typhoons. In one of the 20th century's most influential books, The Structure of Scientific Revolutions, Thomas Kuhn wrote, "Philosophers of science have repeatedly demonstrated that more than one theoretical construction can be placed upon a given collection of data." Kuhn was advising us to be careful and distinguish good data from the opinions of claiming the data supports their pet theory. This illustration graphically represents the collection of data describing how the energy absorbed by the sun each day escapes back to space via waves of long-wave radiation. It is solid, undisputed science based on theory and observations from satellites and laboratory experiments. It is the foundation of the greenhouse theory upon which opinions regarding various climate crisis theories have been constructed. The laws of physics have theoretically determined how much energy each infrared wavelength should transport back to outer space for a given surface temperature if there is no atmospheric interference. This is represented by the blue curve. For non-physicists, it is helpful to think of infrared wavelengths as roadways carrying solar heat from the Earth back to space. Wavelengths between 20 and 50 microns should act like interstate highways carrying the greatest flow of heat, while wavelengths of 5 or 40 microns act like dirt paths, allowing very little heat transport. The black jagged line represents how much energy each wavelength is actually transporting back to space, as observed by satellites. The difference between the blue and the black curves represents an undeniable greenhouse effect. This is all excellent data in settled science. But beware, this data does not determine how long infrared heat will be trapped. Greenhouse gases only serve as detours, not permanent traps. Those detours simply delay the time needed for heat to escape to space. Not understanding this crucial point has led to many absurd theories of a climate crisis, mass extinctions, and much weeping and gnashing of teeth. CO2 is indeed a powerful greenhouse gas because it absorbs wavelengths centered around 15 microns that serves as a major interstate highway for heat escape. CO2 forces half the theoretical heat to take a detour. CO2 emits any absorbed heat in less than a second and emits those wavelengths in all directions, with half redirected back to the Earth's surface. It is this redirected heat that is believed to warm the surface. In this illustration, the green line separates absorption by CO2 from absorption by water vapor. The red line shows that by doubling CO2, it only increases the amount of redirected heat by 1%. Water vapor absorbs much more heat from a wider range of wavelengths. Dry desert climates lacking water vapor experience a reduced greenhouse effect. Heat can escape more freely so that nighttime temperatures rapidly plummet by 50 to 100 degrees Fahrenheit despite a remaining CO2 effect. More importantly, there are also wavelengths that always escape freely to space, providing an atmospheric window that allows about 15 to 20% of the Earth's energy to escape without delay. That window also provides the escape detour for the redirected greenhouse heat. Although redirected energy is transported by specific wavelengths of water vapor and CO2, it has a more general effect. A warmer surface now emits the entire spectrum of wavelengths. So 20% of CO2's redirected energy now escapes freely through the atmospheric windows, counteracting the warming. The process repeats and continues throughout the night, dropping surface temperatures lower and lower, back to their early morning minimums. So despite added energy, the greenhouse effect doesn't trap heat for very long. Now, extreme heat waves caused by heat domes operate in a manner similar to a car with its windows raised. It doesn't matter how heat is radiating back to space, but for how long warm air is trapped close to the surface. The longer the windows are up during midday sunshine, the higher the temperatures rise. At midday, in 80 degree Fahrenheit heat, temperatures inside your car can rise by 43 degrees to 123 degrees Fahrenheit in just 1 hour. Tragically, not realizing how quickly heat can accumulate, pets and children left in cars can die. To reach 123 degrees Fahrenheit, the car's rate of energy gain was at least 154 watts per meter squared for a full hour. A watt, for your information, is a measure of energy per second. Now, increased CO2 only adds about 2 watts per meter squared, so it would be silly to argue that rising CO2 made the car hotter when just lowering the windows would eliminate the extreme temperatures. The important dynamic for people to understand is suppressed convection causes extreme temperatures. The ground, heated by solar radiation, sheds that heat in 3 ways: by emitting a spectrum of long-wave radiation, or by cooler air absorbing heat when contacting the ground, and by convection that carries the heated air towards the stratosphere. Without convection, the Earth's surface would trap surface heat like the car with its raised windows. Convection not only causes warmer air to rise, but allows cooler air from higher altitudes to sink. The mixing of cooler air further reduces surface air temperatures. Carrying warm air up to the stratosphere is also crucial for cooling. You can see where the stratosphere begins when a rising rain cloud flattens out as it reaches the altitude where the stratosphere begins, called the tropopause. At that altitude, the air is about 100 degrees Fahrenheit cooler than the ground. The air has cooled due to both lower air pressure and by radiating heat back to space. However, if the air doesn't radiate heat away, cool air would simply warm back to its original temperature as it sinks. So how does 99% of the air molecules that are not greenhouse gases, mostly oxygen and nitrogen, radiate away the heat they absorb from contacting the ground? CO2's warming effect is greatest at low altitudes, where it is largely saturated. So future increases of CO2 will have a smaller and smaller warming effect. Unfortunately, clickbait media rarely informs the public that CO2 also has a strong cooling effect, increasing emissions in the stratosphere and mesosphere. Satellites observe that the stratosphere is cooling twice as fast as the lower atmosphere is warming. Warmed oxygen and nitrogen can shed their heat by colliding with CO2 and transferring its heat, so CO2 can then radiate their heat away. In contrast, Heat waves are caused by suppressed convection in the lowest 6 kilometers of the atmosphere that prevents rising air from reaching the stratosphere and cooling radiatively. Heat domes trap heat for days. They are high-pressure systems where sinking air inhibits convection and reduces cloud cover, which also increases solar heating. Canada's record high temperature was set and then reset 3 days in a row at the end of June 2021 in Lytton, British Columbia. The final record was 45 degrees Fahrenheit warmer than the average maximum temperature for June. A difference is intriguingly similar to the increased temperature of the car with its raised windows. Southwestern Canada's heat wave was caused by an exaggerated ridge in the jet stream known as an omega block. Omega blocks regularly cause high-pressure systems that linger in one location. As the block remained in place for days, more heat accumulated in each day, driving Canada's record temperatures higher and higher. Clickbait media like CNN clearly doesn't know its geography. They ranted that this very local heat dome was evidence that climate change is frying the whole northern hemisphere. However, science doesn't support CNN's rants, as climate models also suggest that any warming should reduce such blocking events. Finally, if we consider that the dryness accompanying most heat waves reduces the normal greenhouse effect, plus the absolute lack of any correlation between heat waves and rising CO2 as seen in this EPA graph, it suggests that all the hype by politicians and the media ranting that heat waves are evidence of a CO2-driven climate crisis is really just unsubstantiated fear-mongering. Now lastly, suppressed convection also warms the oceans, causing layers of trapped heat that can warm the air and intensify hurricanes and typhoons. There is a scientific consensus that no matter at what depth heat is absorbed, it is trapped in the ocean until it rises to the micron-thick skin surface, the only place ocean heat can escape. However, when there is a salinity gradient with fresher water at the surface and saltier water below, despite being warmer, the denser, saltier water suppresses convection, preventing it from reaching the skin surface to cool. Now, humans have taken advantage of that salinity effect by creating solar ponds that generate useful heat to warm buildings and greenhouses or generate electricity. Solar ponds maintain a bottom layer of dense salty water at about a 6 to 10 foot depth where solar heating is greatest. Those dense layers trap penetrating solar heat, raising the bottom layer temperature to as high as 190 degrees Fahrenheit, despite air temperatures of only 68 degrees Fahrenheit. Similarly, salinity gradients in the ocean trap heat in subsurface layers, maintaining warmer ocean temperatures from the tropics to the Arctic. Surveys in the tropical oceans observe that the upper 20 to 40 meters will usually be well mixed by the winds and currents, so that the layer has similar salinity represented here by the blue line, as well as similar temperatures represented by the black line. But between 40 and 60 meters depth, increased salinities trap solar energy, and slightly increased temperatures where we would otherwise expect cooler temperatures due to declining solar penetration. Oceanographers call the layer the barrier layer because it stores heat and prevents colder, deeper water from mixing with the surface layer, thus making surface temperatures warmer. In contrast to this solar salinity heating effect, there is no obvious mechanism demonstrating how greenhouse infrared might warm a solar pond or the ocean. All infrared energy redirected towards the surface by greenhouse gases never penetrates deeper than a very few microns into the ocean's skin surface layer. A recent tropical ocean study measured 410 watts of greenhouse infrared energy penetrating a few microns into the cool skin surface. However, the cool skin surface immediately radiates away all the heat that reaches that layer. In this study, the heat emitted from the skin layer accounted for all the infrared heat from the atmosphere plus any solar heated subsurface water that had risen by convection and conduction to the skin layer. Solar heated water requires more time to reach the skin surface and ventilate. Thus, it is most likely that any ocean warming is driven by trapped solar heat that is mixed downwards. Now, there are well-studied natural mechanisms demonstrating how oceans create and maintain salinity gradients that trap subsurface solar heat. In the simplest of terms, regional differences in evaporation and precipitation produce the required salinity gradients. Atmospheric circulation, or the Hadley circulation, creates regions of descending air and high pressure that generate clear skies, greater solar heating, as happens in heat waves, and high rates of evaporation with very little rainfall. Saltier water is produced there. As illustrated by the red regions, these so-called ocean deserts happen at the same latitudes where the atmospheric Hadley circulation maintains deserts on land. The trade winds then blow that saltier water towards the equator and westward. The trade winds also blow the evaporated water vapor towards the equator, where it converges and then rises and produces the world's greatest regions of rainfall around the equator, here represented in blue, and named the Intertropical Convergence Zone. The copious rainfall maintains the salinity gradient with fresh water on top of the warm, salty water below. These combined dynamics constantly provide the needed ingredients to produce permanent heat-trapping barrier layers. The solar pond heat-trapping mechanism forms the Earth's greatest reservoir of heat, the Western Pacific Warm Pool, which stores solar-heated water as deep as 200 meters. The warm pool grows during La Nina-like conditions and shrinks when an El Nino event ventilates that heat. During La Nina-like conditions, the amplified trade winds blow the warm, salty water into the Western Pacific Warm Pool. Simultaneously, colder, deep water upwells in the Eastern Pacific, permitting a high-pressure system to form that amplifies the trade winds and creates clearer skies and greater solar heating. As a result, the Eastern Pacific, or Eastern Atlantic, illustrated here by the blue regions, absorb and trap more solar heat than any other regions of the Earth. That stored heat is eventually transported around the world, where it ventilates and warms the atmosphere. The regions illustrated in red represent where the most of that trapped heat ventilates, warming those latitudes several degrees higher than possible if there was no ventilated heat at all. For example, heat ventilating from the Gulf Stream is why Western Europe's winters are milder than similar latitudes in North America by 27 to 36 degrees Fahrenheit. These dynamics contribute to the recent 150-year global warming trend, as the tropical Pacific's dominant El Nino-like conditions during the Little Ice Age switched to a predominant heat-absorbing La Nina-like conditions this past century. Intriguingly, based on scientific estimates of the speed of the global conveyor belt's transport, heat now ventilating in the Arctic and reducing sea ice may have first been trapped in the Pacific Ocean 200 years ago. It is also the trapped heat in tropical warm pools that enables tropical storms to evolve into hurricanes. and the Pacific warm pool with its more permanent barrier layers enables hurricanes with the most intense wind speeds, designated as Category 5 hurricanes, to develop. Uniquely, in the tropical South Atlantic, hurricanes virtually never form because waters heated in the tropical South Atlantic circulate across the equator and get stored in the North Atlantic warm pool. In 2005, 3 Category 5 hurricanes struck the United States, prompting a flurry of clickbait media headlines proclaiming global warming was making more fierce hurricanes that also intensify more rapidly. Thus, rising CO2 will continue to make hurricanes more deadly. But examining the different 2005 storm tracks of Hurricane Wilma or Hurricane Katrina reveals those 2005 hurricanes only reached a fierce Category 5 status for a very short time and over a very small local area, and not when making landfall. Thus, it is regional ocean warming that is much more likely to be the cause of any intensification bouts, not global warming. Political fearmongers do not hesitate, though, to weaponize the societal damage and human grief caused by hurricanes. So they cherry-pick the brief Category of 5 stints to blame rising CO2, while ignoring the dynamics causing hurricanes to exist for most of their lifetime in a much weaker condition. Fortunately, Mother Nature quickly counteracted the blatant fear-mongering. For the next 9 years, the USA experienced no intense hurricanes, leaving most climate experts without any explanation. Despite persistent clickbait media headlines from the New York Times or National Public Radio claiming CO2 is making hurricanes more deadly, good solid science finds no correlation with rising CO2 and hurricane frequency, and no correlation with any increased frequency of the most intense hurricanes, Categories 3, 4, and 5. Yet, as expected, the 150-mile-an-hour winds at landfall from the 2022 Hurricane Ian provided an opportunity for The Guardian and the world's worst alarmist climate scientist, Michael Mann, to fearmonger, claiming a climate crisis is causing more powerful hurricanes. Hurricane Ian was a Category 4 when it made landfall along the western coast of Florida. Mann emphasized that Ian was the 5th strongest hurricane to ever make landfall in America. But Mann avoided sharing the inconvenient truths that Ian was tied with 5 other Category 4 hurricanes, such as the 1919 Florida Keys and 1932 Freeport hurricanes, or the strongest landfall was the 1935 Category 5 Labor Day hurricane. Mann also failed to share that numerous peer-reviewed studies have documented that short bouts of hurricane intensification happen when they pass over the stored heat in ocean barrier layers. The Gulf of Mexico and the Caribbean Sea experience a shifting mosaic of warm barrier layers. Multiple studies have shown that barrier layers supply the heat needed to intensify a hurricane, as well as preventing the typical upwelling of cooler, deeper waters that weaken a hurricane. Still, in order to push his pet theory that all things are possible with rising CO2, Mann's Guardian article never mentions barrier layers at all. To produce the salinity gradient for a barrier layer, the Amazon, Orinoco, and Mississippi rivers supply seasonal plumes of fresh water, highlighted here in blue, into the Caribbean and the Gulf of Mexico. The loop current erratically transports deep, warm, and salty equatorial waters northwards towards the Gulf Coast. It sometimes veers quickly to the east to join the Gulf Stream, or 2, it sometimes loops much further northward, and 3, sometimes those loops pinch off to form meandering warm eddies. Whatever the case, when hurricanes pass over a region with fresh river water above warm salty loop current waters, below, the hurricane intensifies. No wonder Michael Mann avoided discussing barrier layers. Barrier layer formation, and thus hurricane intensification, has nothing to do with rising CO2 or climate crisis. Clearly, there are many proven dynamics that trap heat and drive warmer temperatures other than rising CO2. If you follow all the science, you will sleep much better knowing claims of a CO2-driven climate crisis is most likely just a flawed theory placed upon good scientific data. By following all the science, I am now sleeping very well. Thank you.